Okay, welcome back. This is Mrs. Galazzi, and this lecture is for honors only. We are going to cover empirical formulas and molecular formulas. Okay, last lecture, I asked you to go ahead and watch the next video by Melissa Maribel on empirical formulas. Hopefully you had time to do that. It is a very good video, very simple to understand. And so we're going to go right past that into looking at actual problems, which will be on your worksheet. Okay, so there's a calculate the empirical formula if a compound has 75% carbon and 25% hydrogen. Okay, and there's a process to find empirical formulas. I know the video told you a certain way how to do the steps. Okay, my way, as far as steps, first you take the numbers that are given and you convert them to moles. So these are set 75%, 25%, they're given in percentages. You could automatically convert, automatically just write them as grams. Okay, I know Melissa told you that in the video. And so we've got 75 grams, 25 grams, 100 grams total. So it's always easier to think of things in whole, 100%, 100 grams, because it makes it very easy. Okay, so you take those grams and you first convert them to moles. And once you've converted them into moles, you look at each number, moles for hydrogen and carbon, and you divide each number by the smallest mole. So if it's hydrogen or carbon, whichever one's the smallest, you divide both by the smallest mole, and then you get two numbers, and then we're going to apply those numbers as a ratio to each element. And so you would put that number with hydrogen and put the number with carbon. Okay, let's go ahead and look at this problem. Okay, we've got 75% hydrogen or carbon, 25% hydrogen, and so we'll go ahead and look at doing this problem. So again, we just write it automatically as grams. Okay, so we've got 75 grams of carbon as a given. We've got 25, 25. I'm just going to undo that because that's just terrible. Terrible, terrible. Okay, 25 grams of hydrogen. Okay, these are our given. And so we're going to first convert them to moles. So the first step is converting to moles. So I've got grams of carbon. I need moles of carbon. Okay, so same thing here. We've got grams of hydrogen. I need moles of hydrogen. Okay, remember to use your units. I'm going to tell you they're very important. As problems get longer and longer, you need to know where your units go, and you will lose points if you do not use units. And you must set this up the way it's properly supposed to be set up. I know some of you will not like that, but you must follow the proper procedure. Okay, so we've got, now we're matching units here to the bottom. Okay, so you're matching. So we've got grams of carbon and we've got grams of hydrogen. Grams of hydrogen, kind of looks like grams. Okay, now where do we find grams of carbon? Where do we find grams of hydrogen? From the periodic table. As soon as you hear mass or grams, you must look them up. Periodic table tells us carbon is 12.01 grams and hydrogen is 1.008 grams. Okay, and per how many moles? What does the mass equal? How many moles? 1 mole equals 12.01 grams of carbon. 1 mole of hydrogen equals 1.008 grams of hydrogen. Okay, so we're going to calculate these and come up with a mole ratio. So since this is the top and bottom, we're dividing. We don't need to do anything here because it's a 1. So we'll just say 75.00 divided by 12.01 grams. And we come up with 6.244. Okay, I'm just going to round it out to about there, okay, because we need 4 digits. So I'm going to use 5 initially. And we've got our 25 grams divided by 1.008 grams, okay, and that comes up to 24.80. Let's do a 2. 802. Okay, so we've got our moles here. Now our next process is divide by the smallest mole. So 6 is the smallest mole. So we're going to divide this by 6.2448. And then we're going to divide this by 6.2448. Okay, and so obviously if you divide up here by itself, you're going to come with a 1. Okay, and this one is going to be, let's see, 24.802 divided by 6.2448 equals, okay, it comes up to 3.971, okay, 971. We have 4 digits here, 4 digits here, so we want to end with 4 digits. Okay, now this is not 4, but it's very, very close. So what we're going to do is, because nothing is ever perfect, right? Nothing is ever a perfect reaction, a perfect measurement, or anything like that. So we're going to assume this is a 4. It's close enough. If you're very, very close, like 3.9, 4.9, 5.9, then you can round up to a 4, okay, for this one. Okay, so we have carbon as a 1. So for this empirical formula, you've got carbon as a 1, okay, which we don't have to write down. And then we've got hydrogen as a 4. So this is CH4 as the empirical formula, okay? So this is the answer for the empirical formula here. And we'll go to the next one. Okay, so now we've got another example of empirical formula. Calculate the empirical formula of a gas compound that has 72.55% carbon and then 27.45%. Now I wrote these wrong again too, didn't I? We can't have both carbon. Okay, this is carbon. Okay, this is oxygen. Okay, so can you tell me, I'm just doing a lot of work and sometimes I make a lot of mistakes. Okay, so 72.55 oxygen, and we've got 27.45% carbon. Okay, good. Now we can go back to that. Okay, so first you're taking these numbers, you are converting them to moles, dividing by the smallest moles. And then once you divide by the smallest mole, you apply the ratio. Okay, I want you to do that on your notes. You should come up with CO2 as your answer for empirical formula. Okay, I give you the answer so you can calculate this on your worksheet or in your notes, and then you can confirm that you are correct. Okay, the next one is calculate 5.000 grams sample of an unknown compound. Okay, so it's unknown, but we're going to figure it out by doing the empirical formula. Okay, now this one is not based on 100%. This was based on 100%, right? This is based on a sample of 5 grams. So we still do the same process, okay? We still do the same process where we're going to use these numbers, okay? So we've got nitrogen, 1.844 grams of nitrogen and 3.156 grams of oxygen. So we're going to do exactly the same thing. We're going to convert these to moles, okay? Once you convert them to moles, then you divide them, okay? You divide them by the smallest mole. And this one actually, when we get the ratio, okay, when we get the ratio, remember Melissa Maribel said if it's like 1.5 or half, then you double it, okay? And so she talked about doing some certain things with them, okay? This one actually ends up giving you a ratio where you're going to have to apply that. So you should come up with something like a ratio of 1 to 1, 1 to 1.5, okay? And so of course you're going to double it, which would make this 3 and this a 2, okay? And so you're going to need to do that. Okay, let me go ahead and clear that. And the answer you will get for this one is N2O3, okay? So calculate this on your notes, and here's the answer to confirm that you are correct, but you need to work it out, okay? Okay, now this video is what I want you to go and watch for this. I don't think there's notes passed here. Let me see. Okay, yes, it is. Okay, so what I want you to do is go watch the Melissa Maribel molecular formula video, and then I want you to come back here and finish this lecture for today. Okay, this will be the last lecture for the week. You won't have anything else for Friday. Okay, and you'll have chance to just use Friday and the rest of Thursday, and of course the weekend if you need it, to finish your worksheet. Okay, so caffeine is 5.170% hydrogen, 16.49% oxygen, 28.86% nitrogen, and 49.48% carbon. Wow, there's 4 of them. Okay, so these are using percentages again, and it says first find the empirical formula. So we're doing that. So of course, all of these are going to be first turned into grams, right? And then you're going to convert them to moles. Once you convert them to moles, then we divide by the smallest mole, and you're going to come up with the empirical formula, okay? Once you find the empirical formula, let me see. I'll write that down for you so you can confirm you got it correct. Okay, so the empirical formula for this one is going to be C4H5N2O. And O, just one oxygen. Okay, so C4H5N2O is the empirical formula. So calculate this on your notes. And then in order to find the molecular formula, you must be given the molar mass. Okay, so what you're doing is you're taking the molar mass and you're going to divide it by the empirical mass, right? The empirical mass. Okay, which is, now you've got to calculate, look up these. For carbon, 4 times 12.001, or 01, 1.008 times 5. Nitrogen's 14.01 times 2, and then 16 for oxygen. Add those up. You're going to come up with an empirical mass. You're going to take the molecular mass, the molar mass, and you're going to divide it by the empirical mass, and that's going to give you a number. And then the number, you should multiply that number, okay, whatever you come up with, this number, you're going to multiply it by each of these numbers to get the molecular formula. So final answer, you should have C8, I'm trying to, okay, let's try this again. Carbon 8, okay, and then we've got hydrogen, you should have 10, and then nitrogen, you should have a 4, and then oxygen, you should have a 2, okay? So that should be molecular formula for you. So calculate these, figure them out on your notes, and here are the answers to confirm whether you got them correct or not, okay? Okay, let's see if there's any other problems. Okay, we're going to go ahead and finish the video there. And like I said, this will be the last lecture you have this week. All you need to do is work on your worksheet that I gave you yesterday, Wednesday, in assignments or activities. And I have it due on Monday. And Thursday, today, I am doing help classes coming on at 10 a.m. or 1 p.m., both of them actually. You are welcome to attend. You do not have to come, it's not required. But if you'd like to have a little bit of help, I would be more than happy to have you. Okay? So 10 a.m. or 1 p.m. And you guys take care. Please message me, email me if you need any help at all. I have done private help classes also with Zoom, so not just public. So if you're having an issue, I have a lot of students even just emailing me saying, hey, what about this? Or ask me a question, and I'm able to respond to them because I often have my emails up and I can see them. Okay, so we'll take care, guys.